All right, welcome back, everyone. I just want to briefly show you a very important concept that we need to understand before we continue, and that's the concept of slip. So, looking at the stator, in the previous video, we said that when we connect our power to the motor, okay, that's our three-phase power, our supplied power, so we supply in the motor with power. The stator sets up a rotating magnetic field. Okay, so the rotating magnetic field in the stator. And we said that was called the synchronous speed. All right, and that's 50 hertz, right, in South Africa. And that rotating magnetic field, moving at the synchronous speed, interacts with the rotor. And the rotor has conductors, and that rotating magnetic field from the stator cuts these rotor bars, these rotor conductors. It moves through them. And what happens is, when a magnetic field moves through a conductor, it sets up its own current in the conductor rotor bars. And those rotor bars then set up their own magnetic field. And the two magnetic fields interact with one another, and it causes the rotor to rotate, right? So we need to have, for this motor to turn, the synchronous magnetic field, the rotating magnetic field, has to be faster than the rotor bars. Otherwise, the motor won't be able to turn. And why is that? So think of this. So this motor, we turn the motor on for the first time. So we supply the power and the motor's not turning. Okay? So the rotating magnetic field is instantly moving at the synchronous speed, really, really, really fast, and it's cutting these rotor bars. It sets up a magnetic field of its own in the rotor bars, and what happens is when two magnetic fields interact, the rotor starts to turn, it starts to rotate, okay? Starts rotating. The rotor now will start speeding up and speeding up and speeding up and speeding up until it gets closer and closer to the synchronous speed of the stator. But it will never be able to reach the synchronous speed. And if it did, what do you think would happen? If the synchronous speed and the rotor speed were the same? And the answer is that relative to one another, there would be no motion, because the speed of the rotating magnetic field would be the same speed as the rotor, and there would be no the magnetic field of the stator wouldn't be cutting the rotor bars anymore, because as it's trying to cut the rotor bars, the rotor is moving at the exact same speed. And maybe a concept that you can, so relative to relative motion. So just for example, say, okay, these two pens, right? If they were connected to one another, and this blue pen was moving slightly faster than the green pen, the blue one would be pulling the green one just very slightly. It would be pulling it along. But if both of these were connected to each other and they were both moving at exactly the same speed in the same direction relative to one another, they would feel like there's no motion between each other, and there wouldn't be relative motion to relative to each other. So if this magnetic field was rotating and the rotor was rotating at the same speed, the rotating magnetic field wouldn't be able to cut the rotor bars because they'd be moving at the same speed, and therefore the motor wouldn't work. So that's the concept of slip. So slip, basically, this rotor is going to be moving at almost the synchronous speed, but not at the synchronous speed. So maybe it can reach 96% of the synchronous speed, but it can't reach 100% of the synchronous speed. And that's the concept of slip. So in the question, they might say, okay, the full load slip is 2%. Then you know that the rotor is going to be 2% slower than the stator. All right. And that's what you need to understand. So maybe they'll say it's 4% the slip. Then you know that the rotor is moving 4% slower than the stator. And yeah, I hope that helps for the problems ahead.